Go over optical isomerism, which is 3.3.7 of the new chemistry A-level specification. So I'm going to start off with what is optical isomerism. So first of all, it is a type of stereoisomerism which we learned in year 1 is basically isomerism which involves the same molecular formula and same structural formula but has different arrangement of atoms in space. Optical isomerism only occurs when there's a chiral carbon, which means that 4 different groups are attached onto that carbon atom. So because of this chiral carbon, the molecule usually has no center of symmetry. So the first thing I'm going to go through is trying to work out whether a molecule has optical isomerism or not. So for example, we have 2-chlorobutane, and what I usually do first is draw the molecule out. Okay, so once I've drawn it out, I can see that there is a chiral carbon with 4 different groups, like so. There's a methyl group, a H group, an ethyl group, and a chlorine. So the answer is yes, this does show optical isomerism with the chiral carbon circled in grey. Another feature of optical isomers is that 2 tetrahedral arrangements will be shown and they will be non-superimposable, so they're mirror images of each other. So we can draw this out. We have the mirror line going down the middle. So on one side we've drawn the tetrahedral shape of one enantiomer, and then on the other side we have the mirror image of it. So this forms the other enantiomer. So basically, enantiomers are non-superimposable mirror images of each other. So enantiomers usually have the same physical and chemical properties. However, enantiomers usually have different reactions with other asymmetric molecules. So this can be very important in drugs, in medicine, because they could have completely different effects. They also rotate plane polarized light in opposite directions. So if we started off with a polarized light ray like this, we would get 2 different outcomes. So one enantiomer will rotate light clockwise, and one enantiomer will rotate light anti-clockwise when we have equal mixtures of both enantiomers. Because they're rotating in opposite directions and equally, this rotation will cancel out. This means that overall there will be no effect on plane polarized light, and this is called a racemic mixture. So that's optical isomerism for the new chemistry A-level specification, and good luck for your exams.